All right. Hey everyone, this is the July 10th, 2019 SIG Auth meeting. We have actually a very empty agenda. I know Tim has an important topic to discuss with us, but I wanted to give anyone else who hadn't had a chance, is there any topics anyone would like to bring up before we move to Tim's topic? I have a feeling that this will take some time. Also, Tim, did you want me to give you a screen share so you can show the slides?
I can try. I've had some issues with screen sharing on my laptop for some reason, so if that
I have the slides open. If you would prefer for me to do it, that is perfectly fine with me.
Yeah, sure. Maybe that would be easiest.
Okay.
I'm happy to have lots of time for this if we want to just jump in.
Cool. All right, let me move over.
Yeah, so I just threw together this deck to kind of help frame the discussion and give folks some background on some of the things we're talking about, and then we can kind of discuss from there. So I'll just take a few minutes to kind of run through these. So I'm assuming that everyone here, you can go to the next slide, assuming everyone knows what pod security policy is. But just to make sure we're all on the same page, it's a built-in policy API. From an end user perspective, this doesn't really matter, but for our discussions, we're going to be kind of going into this built-in piece later. And really what it is fine-grained authorization on pod security settings, since authorization is just at the resource level, but what you're capable of doing if you can run a pod is really dependent on some of the settings on that pod. And so you can go to the next slide. And so that kind of gets into the goals of what pod security policy is doing for us. Sort of the primary goal is that being able to create a pod or any sort of thing that creates pods on your behalf, we don't want that permission to be equivalent to root on cluster. And without any sort of policy limitation, being able to create a pod means you can create a privileged root pod, escalate to the node, run that on all nodes, take over the cluster. So running without this is equivalent to having root on the cluster if you have that permission. Some kind of secondary goals or other uses for pod security policy are to sort of separate the security decisions from the people running the applications and potentially the teams or people who kind of have more of that knowledge of what the dangerous settings are. And so this lets us do things like have administrators who encourage best practices by saying, like, this is the pod security policy that you must all, here's the policy that you need to conform to. And it also means that, if you have a separate security team who understands the low-level Linux security details, then they can write the policy based on what's considered safe there. So next slide. So pod security policy has been stuck in beta for a long time. I think it might have first gone into beta at like 1.3 or 1.2 or something. But there were a lot of bugs in it, and we sort of brought it up to our beta quality standard around 1.8. It fixed a lot of issues. Then it hasn't seen a whole lot of development aside from adding a few new features since then. And it's opt-in. And so I would say this current status is it's pretty confusing to enable. This is my impression from talking to a lot of customers and users and kind of explaining to them how it works. It is opt-in. We'll go into this more later. So actually, maybe let's just move on to the next slide. So this is kind of where the confusion comes from. And sort of the first what I consider maybe the biggest problem with pod security policy, is the way that its authorization model on policies works. By the way, if anyone has questions or comments on these slides, feel free to interrupt me. Just a bit of background, the way authorization on pod security policy works is you create a pod security policy resource. That's a cluster scoped resource. But on its own, it doesn't do anything. And so what I need is an RBAC or some other authorization to say that I have permission for the use verb on that pod security policy resource that I've created. Or the pod service account, the thing that you're creating, the identity that it's running with, that has the use permission on the PSP resource. And so there's kind of these two different ways of using it. And the first is really the intuitive one, like I'm creating the pod, do I have permission to use this thing? And so that's kind of where people default to and where they start with, and that's wrong. I'm just kind of say that confidently. If you do it that way, then it's going to break any future controllers, anyone else who needs to go in and edit that pod after the fact. And so the better way of doing it is through granting the service account permission. Also, generally, users shouldn't be creating pods directly. They should be going through some sort of controller, a deployment replica set, etc. And in order for that model to actually work, since the controller doesn't have permission to use the pod security policy, you have to grant it to the pod itself, the pod service account. And so, but just the presence of that first model creates a lot of confusion, and it actually weakens security. For instance, you can't have a privileged controller that creates pods and have those pods be enforced through the pod security policy mechanism, because that privileged controller needs permission to use the privileged pod security policy. Therefore, anything it creates also has permission to use that. So next slide. Or any questions on that before I move on?
So in that previous statement, you were saying the challenge is that once you've provided access to a particular pod security policy, it has that access to that policy for any pods that it will create, not just the ones that are specific to that user. Is that your point?
So as Tim, if I create a pod, if I grant myself, or someone grants me permission to use the pod security policy, then I can create a pod using that security policy. But I can't create a replica set that creates pods using that security policy.
I see. So you can't associate it with a with a specific result from a controller.
Yeah.
Okay.
So I mean, this is why it gets granted to a service account inside of a namespace scope, so that a controller doesn't have to be privileged and can still create the pod that has this power, which gives you benefits like not everyone can run as root.
Yeah.
That's a general problem with Kubernetes that is not specific to pod security policy necessarily.
Yeah, it is.
Well,
the controller model is
a
fundamental.
boundary. Yeah.
Yeah, the controller model is fundamental, but erasing delegation history does not preclude a controller model. So.
Well, no, I think we're saying that's bad. That Kubernetes, there is nothing in Kubernetes that in any way enables delegation at all, except for the controller model. We have no primitive in Kubernetes that makes delegation easy.
Exactly.
We have impersonalization, but it's not quite the same thing. I mean, it could be used in that way, but.
Yeah, and we talked about the act of impersonation of service account was actually originally intended as the thing that would allow a controller, but it didn't scale, and we never put any more time into it. Tim's right. Like the very first design said, well, we can't go solve the controller delegation problem without spending 2 years and a bunch of theory because we've never seen a good model and we don't know whether the controller model is even going to work. So we'll just pick the delegation. We'll pick the the service account use model because that's the best we had, and we just went with it 4.5 years ago.
And I think it fits in the model of, like as you called out earlier in the deck, the idea of separating the concerns, right? Having an operator and having that operator understand what components are handling the creation of pods and associating the right permission set with them rather than with particular users. Because the user could be a group, the user could be ephemeral, right? But managing that pod over time is actually is important to keep separated. So I'm not opposed to the service account model. I think it makes sense.
Yeah, I think Tim, I would say like the dual model weakens security on this. Like it's hard for people outside to understand what that means. And I don't know
Sure.
that it's like the thing we really want to say here is you grant anybody who can create pod, you've done something better, which is great. Anybody who can create pods is root on the whole cluster too. Anybody who can create pods can do the maximum of permissions that namespace can do, which is better, but it's not really far enough.
Yeah, I mean, we saw issues where people were running a controller manager against the unsecured port, and so it was implicitly a super user. And so I think it's actually worse to say, here's a policy tool, you can lock things down, and people think they've locked it down, but because their controller manager is a super user, they actually haven't locked anything down.
It's also confusing that you can actually bind that type of permission to a specific namespace. So I've seen models and actually even heard promoted models where people are saying, just bind it to all of the service accounts that the controller manager has to a specific namespace, to a specific policy. And in this way you can limit, but that's very confusing. I mean, like in this way you can limit what pod security policies are relevant to a given namespace.
I mean, pod security policy was always intended to protect the nodes, basically. Like, what can you tell a pod to do that would prevent it from doing privilege things or root level things or privilege escalation things or host volume things on a node? And so, like, being able to scope it to a namespace is interesting, but we don't actually have controls at the namespace level that force specific namespaces to be associated with specific nodes. There are like alpha level admission plugins, but we don't have policy in place that says, all right, you can only create privileged things in this namespace, but you can then turn around and say, all right, well, create a privileged thing in this namespace and send it to any node. So it's like there's this chain of policies that are required, and pod security policy is like one link in that chain, but it's not sufficient.
It's interesting though. I mean, you raise a good point, and this is actually my main concern in this conversation, is that with the changes to things, pulling out things that weren't, heavily used in kubelet and mechanisms like that would limit the things for like privileged containers and those sorts of things locally. Now, literally, this is the only line of defense, flawed though it may be. This is it, right? Like if I wanted to actually limit the access to host path, which I consider also one of the, the biggest wide open doors in the world. This is my only defense.
So it's not, I don't think the problem is that we're removing this line of defense, but I think the problem is that there are some checks that are independent of the subject of making the request, and then there are some checks that are dependent on the subject making the request. So if the pod has a specific service account, that's independent of the person making the request, and then if the person making the request is a service account, then it is a dependent check. So I think the proposal is to move this more towards a requester independent check, where it's only dependent on where the object lives or where the pod lives.
Okay.
So you would still have that control.
This is a good discussion. Let's table it until we get to kind of later on, and we'll go more into solutions. I want to kind of finish going through some of the problems that we're trying to solve.
Sure.
The first hour will be enumerating the problems.
There's only two more. So the second problem is that sort of because of the way pod security policy is, you could call it fail closed. What I really mean here is that if you have no policies or you don't have permission to use any policies, then by default, you cannot create any pod. This is, sort of generally considered a desirable property for security. This means that, by default, once you enable pod security policy, you are secure unless you've explicitly granted access to something. But it means that it's very difficult to roll out pod security policy, since you need to have it, if you're talking about an existing cluster that you want to enable it on, you have to have policies lined up for every single thing running before you can enable it. And there's no dry run mode. So that's a very scary bit flip when you turn that on.
I will raise the point, there are a number of organizations that are actively working toward making this an easier prospect. I mean, even EKS now has a reasonable, permissive and restrictive policy when you enable pod security policies within that cluster. So although I do agree it's difficult to roll out, I don't think it's very difficult. And I feel like it's getting easier as we gain more adoption and more people are playing with it.
Does that just move the issue from one of enablement to one of, like, the scary moment changes from being turn PSP on to, all right, remove the permissive policy?
I mean, speaking on our part, like, that was our concern, was like, we don't want to, shoot everyone in the foot, and kind of gave the gun to everyone else to shoot themselves in the foot, but didn't load it, right?
I'm not sure that's better.
It's an important tool, but I think that, it's a powerful tool, I should say, having, being able to define policy that restricts, specific things at a cluster level means that you're going to affect the ability for particular things to run. And this is definitely a pain point that I see every day in working with people with this stuff, right? In that, a controller has created a pod, but it doesn't understand that particular pod security policy would apply, and it doesn't know how to adjust for that. So it is a painful thing, but at the same time, the ability to atomically associate pod security policies and work around these things is another powerful tool at our disposal, right? That you can tie it to a service account. That I can say, this operator with this service account creating these pods has a more permissive policy because I need it to until I can get that bug fixed. It's pretty important.
Yeah, there's no disagreement about that property being important. I think it's more a question of PSP only has the all or nothing approach as far as enablement. Like Tim said, you have to fully account for every workload running on your cluster. You can't dry run it against one namespace or canary it against one namespace easily.
Yeah. Normally, I see the dry run thing happening in different environments. So, I don't enforce admission in dev, but I do enforce admission in staging, and from staging, I do enforce it into production. And so that's where I find some success with customers in trying to figure out a path toward it. Is that promotion model? You've
seen that with PSP, where you run PSP in non-enforcing mode.
Yeah.
PSP doesn't have a non-enforcing mode. Is that a
Well, you would define the pod security policy within the construct of the development environment in which it doesn't do anything, right? But at least at that point, we could do things like use Cisco's PSP advisor, Sysdig's PSP advisor to see if the pod has actually got enough relevant information to define a reasonable pod security policy, or give it a place to give it a starting point so that people could actually define these policies. And then when this work is promoted, when this particular pod security policy is then promoted to staging, we can see what falls off the bus, right? And fix it in staging.
That works in some deployment environments where others are using shared clusters between environments.
That's a very good point.
And so kind of one more thing to mention on the opt-in nature of this, sort of because it fails closed by default, it has to be opt-in. And because it's opt-in, it's hard to get sufficient test coverage. With every other opt-in feature, you get this big matrix of feature, what features are on and off. And it's also impossible to make it part of the conformance suite because it has to be optional behavior. So moving on to problem 3. This one is, I would say, the least important, the least significant of the problems. It's more like just PSP has evolved over a period of time, and this has led to some kind of confusing, messy APIs. This is all easy to solve with a V2 API, or maybe we don't even need to solve it. But a few things to just call out here is that we've gotten a lot of requests over the years for adding in more controls to pod security policy. Some of those have been added, and it's kind of grown in complexity. And some of those we've kind of put our foot down and said no. But there is this desire to sort of build this more powerful policy mechanism and have it work for all sorts of niche use cases. And also, pod security policy doesn't really compose with other policies, since it's sort of an allow you have to have a single policy that allows everything in the pod in order for it to be accepted. So you can't have, say, like one policy that deals with the privilege aspects and one policy that deals with the volume aspects. You can sort of make that work across different admission controllers, because admission controllers are sort of constraining by default. So you say, like, it has to be accepted by all of these, but then you end up just having to build pod security policy into your other admission controllers, essentially. Mutations are confusing. And then also kind of going back to the original goals of saying that, like, you don't need to understand the details of all these Linux security knobs, and that you can sort of delegate that to other teams. I'd argue that pod security policy doesn't do a great job of that, because you still have to understand things like, well, if you're running as non-root, then you should also really enable or disable allow privilege escalation. If you disable allow privilege escalation, that's going to break utilities like ping, and all sorts of fun gotchas like that. So let me try and wrap this up quickly so we can get on to more discussion. So let's skip ahead to some of the options that we have. I think the three options that I know that are on the table for how to move forward here is to fix some of these problems that I called out in pod security policy. That's kind of what we started to get to, of like, well, could we bind the policies to namespaces or figure out some sort of delegation model? Figure out some way of cleaning up the deny by default behavior so that we can enable it more widely. And then we would need some sort of migration path to this V2. And I don't want to go in too much into the details there, but kind of that's an option on the table, is to fix pod security policy and bring it to GA. We could also say we're going to start over from scratch with a new entry policy mechanism. This could kind of go in, I could see this going in two different directions. One would be to say, let's distill pod security policy down to the bare essentials. Like, what are the sort of the fundamental minimum things that people need to be able to constrain to run a cluster safely? And for all of the other niche use cases, there's plugins. The other direction would be to go for a really flexible policy mechanism, maybe sort of like an OPA Lite, that would let you cover all of those niche use cases in this kind of fancy policy mechanism. And maybe we could try and make it ways of simplifying it as well. That starts to look a lot like Gatekeeper built in tree. So yeah. And then the third option is say, well, the space here is too large, and we have this nice webhook mechanism for arbitrary admission controllers. So let's leverage that ecosystem and move this behavior out of core. And so we could actually take the existing pod security policy controller and move it to a webhook for people who have are already depending on that functionality. And then work towards standardizing the community around some sort of policy framework. And I think Gatekeeper looks particularly promising here. It's still in early development. And then I don't know if there are other suggestions as well. Then I have a few slides on Gatekeeper as background, but maybe we can kind of save those and if that comes up. And then, yeah, so that kind of wraps up the presentation. And I'd like to open it to discussion now.
So one of my concerns, I mean, you highlighted that like perhaps pod security policies don't do an incredible job of providing a lot of detail around what will happen when you enable particular flags and that sort of stuff. But at the same time, I feel like it does a reasonable job of exposing those knobs that define the constraints that should be necessary for operators to secure Kubernetes, even in some reasonable way. And so I feel like having a core API that, even if it's just the distilled PSP essentials, I feel like having some core API that does give you a mechanism that a way by which to learn what those knobs are is pretty critical to the product, in my opinion.
It does that well for Linux containers, but it doesn't work so well for Windows and VMs. The attributes are varied by runtime. It's a pretty ever-growing surface.
I know personally, I don't really have a strong opinion as to how PSP should build, but I'll say that number 3 sounds like bad things waiting to happen. It kind of reminds me of roll your own authentication, roll your own crypto. A lot of people really don't know how to do this stuff correctly. You're going to think they've done it beautifully, and goes back to the, well, we think we have it locked down, and really it's wide open.
Number 3 is leaving the option to roll your own open, just like there's the option to run a cluster with a custom authorization or authentication webhook today. But what I'm suggesting is more that we lean on the ecosystem and even contribute as SIG Auth contributors towards developing some of these options and building best practices around here's something that we endorse and we think it solves the problems. The difference is kind of, does the code live in github.com/Kubernetes/Kubernetes or somewhere else?
So I certainly agree with the idea of making it extensible. I guess the caution I would put there is once you move it outside of the tree, you have to do more than just lock down your cluster. So I'll give you an example, OPA. With OPA, you're usually importing a lot of information from the cluster into that internal database to make decisions. Well, most people don't actually lock down that import process. Most people don't lock down making sure that they're validating the tokens that come in. They're trusting Kubernetes as it goes. So while it would require a really specific attack to be able to compromise those things, fact is that if you're blindly trusting the data inside of that database without having a way to know that it's protected and audited, you're leaving yourself open. So I would just argue that number 3 shouldn't be the first place to get. If you have a specific use case that needs something outside of whatever PSP becomes, then yeah, 3 should be a good option. Because if you're going there, then there's an expectation, you're going to have at least some expectation as to what you're doing. But I think as a starting point, it would be a really bad idea.
I think the Unix philosophy is at odds with easy installation and setup, which I think aligns with what you're saying. For 3, my big, I guess my motivation for policy in tree is to, firstly, to secure Kubernetes core components, and secondly, to provide portable applications with a reasonable level of security. The second one, I don't think has really happened with PSP, considering that basically all Helm charts fail with PSP enabled. It might get better if it was on by default or it was more broadly used. And I don't know how it will be affected with something that is outside of core. But it might not. It might fragment the ecosystem more with policy in this space.
I like the from world. It's cozy, you know.
My concern is that I spend a good amount of my time teaching people how to learn the API or to make use of Kubernetes in general, right? So basically, helping them level up on how to make all of this work for them in their organization. Somebody really loud on the mic. So I feel like it needs to be in core because it gives us a place to start with that, right? We need to have some way of understanding what those knobs and dials are that are like, as you said earlier, put forth by SIG Auth as a reasonable set of controls with which to define what a secure pod implementation might look like inside of a cluster. If it's outside of the cluster, I feel like this would be defined in ways that are incompatible with each other, and I feel like it would go sideways very quickly and it would be very difficult to level people up on it. I do agree that it should be extensible and that it's entirely possible to do this with a webhook model, and I don't see any reason why people wouldn't be able to do that in the future regardless. By understanding what the resulting pod security policy might do to affect a pod's configuration and define mutating or validating webhooks that give you that control. But I don't think that should be the immediate goal. I feel like defining what the proper surface is and allowing people to learn it is critical.
I think part of the issue is that it's not clear what the proper surface is. So the ramp from like the simplest version, which is don't let me root the cluster because I can create a pod. Well, that's actually pretty easy. Just disallow tons and tons of stuff in pods, right? Like drop all capabilities and don't run as root and don't allow any volume mounts except like the config map and secret and PVC ones, and like just disable a bunch of stuff in pods. But then the next issue is like, oh, well, we were using some of that. So now we need like all this fine-grained stuff. And then that's just kind of in the allow, disallow category. Then the next level is, oh, well, I want to like change incoming pods. So I want to, like Tim mentioned, separate the person authoring the pod from the person managing storage. And so now you have like, oh, well, when a pod comes in, stomp in like an FS group so that they can access the storage. And some of those things layer in pretty easily, and some of those things, when you try to change pods, they just break pod processes horribly. And then you have the next step, which is kind of the extensibility aspect, where you get all these crazy policies like, oh, well, if a namespace has this label, do this, or if it's in this namespace, add this scheduling aspect. And so like for in-tree policies like this, there's always pressure to like add one more knob, add one more use case. And if this is being held up as a policy that people should use, and it, like Mike was saying, there's portability and like everybody includes a pod security policy or whatever the in-tree policy is. But then the ramp, as soon as you want to do anything, like one step above that is, okay, re-implement everything. That's a pretty difficult story.
I think the challenge there, though, is that's going to be true regardless, in my opinion, right? Like whether you do this with an external mechanism and you're defining your policy through Gatekeeper or some other policy framework, or whether you're doing that through pod security policies, doesn't really change anything except, I mean, the surface is the same, right? You're still going to have to figure out, where you have brittleness and how to adjust for it one way or the other.
Yeah, but if all of them are done with Gatekeeper or some system like that, then the selection and composition mechanics actually can work. Like the sort of stock policies that keep a pod from rooting the cluster can be applied to namespaces in the same way and audited in the same way and dry run in the same way that your custom policies can. I think that the difficulty is when you start mixing policies from different layers. So like if you had a pod security policy that was doing one thing, and then to do like a scheduling policy, you had to do a webhook that did something else. Those are now like controlled and audited and applied in completely independent ways.
I think based on the experience we have from the past several years working on this off and on and how things have progressed, that we are more likely to succeed by turning something over to out-of-tree external implementation so that people feel empowered to go out and try to solve this problem. And maybe they come up with something new we haven't even thought of. Maybe it works better, but we built these extensibility hooks for a reason, and we haven't done a great job in tree, so it seems like the best option we have.
Yeah, I guess what I'm trying to understand, I sense a little bit of pushback on 3, but I'm trying to understand what we have actually gained from having PSP in tree other than the slow feature creep that it's had and sort of.
So I'm not necessarily pushing back on 3, and I don't think 1 is going to happen. But things can start out of tree for experimentation and can live there forever, or they can be eventually adopted. So it's 3 does not preclude us from doing 2 eventually. So I think.
Sorry, Mike, finish.
I just think we're not exactly. I'm personally not pushing back on 3, but I am noting some downsides to it. Go ahead.
Thanks, Mike. Lockie here, just speaking as a representative Gatekeeper, the Gatekeeper project. I think one of the exercises we're taking a look at in the Gatekeeper community is trying to build out PSP to see what it would look like. So taking all the policies that it currently supports and the way that it works and modeling that in Gatekeeper and having a look at how that operates would be probably something that's fairly beneficial for both sides, just to get a grok of that. And then, shipping, a blessed set of APIs that constitute where PSP is today may be helpful for the community. And there's probably no reason Gatekeeper couldn't even ingest the current set of APIs and model them in, the language that's there as well. That could also be a possibility. But the Gatekeeper project, there's several representatives, Rita and Max, on this call, are interested in, we're kind of got a much larger scope, and what we're seeing is customers saying, how do we generically solve policy on Kubernetes? And what you've got is this disconnected, we go and do this PSP thing to get this stuff, and then we go and do this other stuff to get this other stuff. Why don't we do it the same way everywhere? And is that possible? So people are saying today, if we have Gatekeeper rather than turning on PSP, because features like dry run are being built into Gatekeeper and audit and things that address a lot of the usability options, people are saying rather than use PSP, can I just use Gatekeeper to solve the same problems? So I think keeping the conversation going with, whatever the decision here is still something that's interesting for the Gatekeeper project as well, regardless of the outcome.
It raises the point that I've seen referred to within SIG Auth a few times, which is that there's a bunch of admission control policies that are predefined within Kubernetes, and if you look back at them, you're like, why are we swatting at flies here? Why are we picking individual pieces and solving them with admission control that's canned in core rather than having some external policy that can be more generically applied across the whole set of business policy that we're trying to apply to a cluster. And I get that, and I agree with it. That for users that are ready to adopt that sort of a model, it completely makes sense to have, a more consistent API and policy framework with which you apply with which you scratch all those itches, whether they are pod security policies or network policies or any number of things. A way that you can define those things, probably not network policies, but you get the idea. Define those things consistently for your organization would be great. To answer Mo's question, I think the thing that we get out of it, and I don't want to belabor this too much, but I think that the thing that we get out of pod security policies existing in core is the ability to teach people what things are important around securing pods, right? Whether they are manifested by some external policy controller, whether we advance the way with which we enforce these things, I think is almost beside the point. I feel like we have to continue to define what knobs and dials are important to think about consistently in some way that is accessible to Kubernetes, to operators of Kubernetes clusters, and having some common definition, I think, is critical.
I think that not being in tree doesn't make that point any less valid. I would say that you can still have that explanation with anyone, regardless of whether it lived in tree or out tree.
Where would you look for it?
Kubernetes documentation.
Yeah.
I mean, that's kind of where we are today. So you already need to teach someone that, hey, there's this thing called pod security policy. You need to go and turn it on. And then you need to also teach them how to use it, which is kind of complicated. There's no reason we couldn't have, a Kubernetes, that same documentation page, like, here's this thing called Gatekeeper, and here's the command to turn that on, and here's a few other options. Here are on the pod, here are the dangerous APIs that you want to limit.
Yeah, I think it makes more sense to base it on the pod API to describe the problem. But yeah, there's nothing that says just because PSP isn't here, we can't explain what this is.
Right, but I think authentication has come up a couple times on the chat side of things, and I think there's an analogy there in that most folks are having a hard enough time with authentication, which is orders of magnitude easier than this problem to solve. And, having to externalize the authorization, at least at the most basic level, I think it's going to create a much higher barrier to entry. Even saying, let's say there is a OPA YAML file that gives you OPA, it gives you the baseline policies that's all set up. Maybe it's even an operator so that everything stays updated. But the second anything needs to change, or somebody needs to understand what that is, or even are the OPA pods built on the version of or the containers built with something that my organization has certified. I think once you start requiring external pieces for something as complex as authorization, it gets very complicated very, very quickly.
Kubernetes has always required some external pieces for things like logging and DNS and various other features. And we're moving towards a model where that's increasingly true with moving monitoring out of tree. One
Sorry.
point. Yeah, go ahead.
Sorry, Tim. I think, cloud providers going out of tree as well, right? Which is a substantial chunk of code in Kubernetes core.
Maybe in tree and out of tree. I wasn't using that for core. I don't think they necessarily need to live in the GitHub repo with everything else. I think that maybe what I was thinking of is better considered, I want to say conformance or standard across Kubernetes deployments. I think that's what is important.
I mean, as we're moving like CRDs towards the process of being PA, right? Aren't we really pushing towards enabling others to build mechanisms on top of Kube, saying that everything has to be in tree?
So that back to the reason for standardization, not necessarily in tree, is that they can we can use functionality to protect core Kubernetes infrastructure. And second, we can allow security for portable application definitions like Helm. We can improve the security posture of those applications for all users. I think those are the reasons for a standard offering across Kubernetes that is conformant, regardless of whether it's in a GitHub repo.
I'll note that I don't think PSPs, like the problem with PSPs is they're a little bit like what happens when you give, when you hard code roles and role bindings to service accounts into a Helm chart, which is there's no actual review there. And so it's possible, but it's just creating another problem in terms of distribution. Like it's what permissions are you actually granting this, and did you understand what those permissions are? It's the portability is in theory possible, but without solving that larger problem, I'm not sure it's even worth it from a portability perspective. I wouldn't want to solve the portability problem without actually not creating a new security problem there of, yeah, I installed the component through Helm and it gave itself privileged root access on the entire cluster, which violates the intent of PSP in the first place, which is to let admins control who can do what.
Yeah, I see.
I mean, operators are almost completely broken unless you have a trusted party reviewing and approving what permissions an operator can ask for. Even today, right? External controller integrations grant themselves read all secrets on the cluster, game over. So I do feel like, you know, the portability aspect of it is overstated when it comes down to it doesn't actually, you know, protect the user the way that the core system is trying to.
Namespace scoping might be a little bit better.
Yeah.
But potentially what Tim was talking about with composability of add-ons and just granting that, or composability of PSPs and granting those to namespaces so they can do the basic stuff might also solve that problem without having to create a specific role binding for a service account that Helm decides to use.
Right.
I mean, in some ways, it seems like there are conflicting goals. Like one of the goals for portability is that the same deployment works on, like I can reasonably expect it to work in different clusters. And there are a couple ways to accomplish that. If you run a cluster that has tighter security settings than most deployment authors consider, like one is to force settings into the deployment or into the pods that make it conform to your stricter requirements. And that like works great for creating the API objects, but in our experience, typically breaks pods when they actually try to run. It's like, it's great that you told me to run as a random UID, but now I don't work. And so I'm not sure if like we're gonna get to a point where deployment authors who don't think about any of these security aspects are gonna be successful running in tighter, more secure environments that do want to enforce like non-privileged, must run as non-root types of things.
Yeah, that's definitely a problem. I mean, it seems like folks like SysDig are starting to kind of address those sorts of things, whether that's through Analyzer or, you know, providing a better audit trail for that sort of stuff as it relates to the events for these things. I definitely think it's something that it's one of the biggest pain points that I see with it out there.
And so pod security policy tried to err like on the side of, I guess, ease of use by like helpfully saying, oh, your deployment didn't specify these settings, I will now go set them for you. Where it probably would have been simpler and maybe like in the end just as useful to just reject things out of hand. Like, nope, you are out of compliance. Like, you can't run these things. You need to go change your deployment. And that would give like back pressure to the deployment authors to say, oh, well, you're running as root privileged with host paths, like, or not host paths, that would be rejected, but you haven't locked down your settings. You need to do that, instead of saying, we'll lock them down for you and then just break the pod processes. And that would greatly simplify like pod security policy, and like thumbs up, thumbs down is a lot easier to reason about than thumbs up with changes that may break things. And some of the things that we had in there were oriented around like force in specific UIDs so that you can get file permissions. Some of that is easier to do now with webhooks, so it's somewhat orthogonal. Like if someone has a mapping of like LDAP users to namespaces, and they say everything in this namespace is going to use this storage, so run it with this UID. Like that sort of thing you can do pretty easily with a webhook now, right? Whereas when pod security policy was first introduced, those didn't exist, and so things like that kind of got glommed into pod security policy. It's like, oh, here's a convenient place to force this UID onto pods. Anyway, I think we need to untangle kind of the goals. Like, are we trying to protect the cluster? Maybe we could do that more simply. Are we trying to give people knobs for like all these security settings to fine tune things? Like at a fine tuning level, that probably belongs in webhooks and extensibility mechanisms. But then there's this big middle ground, and there's always disagreement about where that middle ground ends.
Yeah, I agree with that. I think what you're getting at is sort of that 2A option. I welcome anyone who's interested in this to put out a proposal for this. But I think like in practice, it's pretty difficult to actually define like what that minimum bar actually ends up looking like. In a way that's not just going to like end up looking like pod security policy in 3 years from now when we add Windows pod settings and all sorts of other things in there.
So part of what I'm trying to understand, are we expecting something like PSP to enable running sort of like random things you find in Helm charts? Like, is that an actual like goal? Like to me, like it makes sense like on a dev cluster to say, okay, I'm going to try out this cool thing that you can run on Q or your Q variant, but like I wouldn't expect that to be a thing you can just lift into prod and say, yeah, it's going to work, right? Because I generally assume that the environment that you have in dev versus prod is probably just going to be tighter in all sorts of ways. So you, as the person who wants to run this component, has to do some extra work, right? But I don't think like we have some generic way to sort of guarantee that, oh, we'll tighten your pod just right. And as Jordan mentioned, it might default it and force it down, but then it might stop working altogether. Like the actual app might stop working.
I think that there are universes that exist where people can deploy pods into their namespaces if they so choose, and most of them work and are reasonably useful. Like, I don't think we have that with pod security policy with the current way that it's granted.
And some of this is like talking one level above where some of the actual problems exist as well. Like the API requests that are made to create pods in a lot of ways are underspecified, right? Like you can omit details and it kind of falls back to whatever's in the container or whatever the container runtime defaults to. And so anything that's doing policy at the API level like doesn't have the information it needs to make a lot of those decisions. And so whether it's pod security policy or external admission or some entry replacement, like a lot of the decisions just lack the information required. And so I think if pods were required to specify fully like the information about what who they were going to run as, and like we could make a lot better decisions. We could catch things a lot earlier, whether it was entry or extensible.
Agree with that.
So living in the universe we live in where they don't have to specify that, I think like trying to guess is probably not great. And so if we're talking about the future for pod security policy, today it tries to guess or default things, and that's almost never successful for most of the things. A few of the more esoteric ones, I think, You could probably drop some capabilities, and if they're rarely used ones, you can be okay. But like forcing in UIDs or forcing things non-privileged, like I said, in my experience, just almost breaks every container that didn't consider it ahead of time.
I completely agree that mutating, for the most part, is definitely hard to reason about, especially because of the ordering thing, right? Like validating will hit first. So anything that you have that might validate, any pod security policy that you might have that validates, it no longer looks. There's no mutation that happens after that. And that's confusing, for sure.
Yeah, so like, for path forward, like Tim said, if people have ideas about like a minimal set, that it probably wouldn't be pod security policy. Like for compatibility, like the existing API and existing admission plugin can't really make a fundamental change like that. If we wanted to do major changes, it would have to be like a separate admission plugin or a separate API. If people have ideas, we're welcome to love to hear them, but it's not clear that that's a great use of time given the things we know would be asked for next, which we probably wouldn't be willing to do built in.
We're just about out of time here, but I wanted to kind of finish with saying that anyone who's worried that like we're going to take pod security policy away, we will not deprecate it or remove anything until there's good viable replacements with smooth migration paths and everything like that. Yeah, don't worry about that going away. This is essential functionality, as I think kind of everyone here agrees on. Like we need things that solve those goals that we talked about in the beginning, and today that's pod security policy, and we're exploring other options that might better fix those, but we won't get rid of pod security policy for a while.
But that's also why when people say, is this going to go to V1, like the problems with the current setup are pretty severe in some cases. And so it's not clear that we want to promote this and say, oh yeah, this is the thing that everyone should be using. Nobody should explore arbitrary things. Nobody should explore alternative, simpler, more comprehensive or comprehensible solutions because this is GA and this is the way. So that's the hesitation and why it hasn't moved forward.
This seems somewhat analogous to the ingress argument in some ways, but I hear what you're saying. It's great to hear that it's not going anywhere in the near term. I think it'll be interesting to see like a race between the adoption of it and things like Gatekeeper picking up where it left off, that sort of stuff.
And I do think there is like a certain amount of urgency that goes with this, like kind of what you were saying, the race of adoption and the other things. Like we need solutions. We need to be able to make some recommendations, yeah.
Thank you for the discussion.
Yep. Thank you.
I guess.
Bye.
Yeah.